Sorry, everyone. I don't know what was going on there. I guess I had to choose between three different microphones and I picked poorly. Good afternoon, everyone. My name is DJ Servino. I'm Executive Director of Research Computing and Networks here in the Office of Information Technology, and I'll be serving as moderator for this tutorial. Before we started and I introduced Liang, what I wanted to do real quickly is just tell you a few of the initiatives that OIT has with regards to research computing coming up. So I'll first start by making a pitch that we always want to hear from you all on our services so that we can provide support for you better. So please feel free to contact us at any time and through any channel you think is appropriate with what your needs are or what you're perceiving in your department in terms of research computing services. Just briefly, some of our main initiatives right now include our HPC move to DC blocks, that is our HPC clusters, which are currently in our secondary data center here on campus, are going to be moved to our co-location facility that we are renting in Birmingham by the name of DC blocks to provide enough power for us to be able to grow and have a little bit more breathing room. We're kind of constrained here on campus because of the power infrastructure. And we are anticipating sometime early in the new year, we'll start moving those different clusters. At the same time, we are also doing our Gordon Palmer data center refit. This is, in order to remediate some of the power issues we have here on campus, we have a project to basically refit and upgrade our current data center. We're right now in the design phase. We're at what they call the 90% design phase, which is we're just kind of dithering over some of the little details we need to focus on. But the expectation is that we'll go out to bid sometime in mid-December and start construction in early January, first week of January. And that'll be a year-long project and will provide us a lot more power in our data center to be able to accommodate growing need from the research community and from the administrative community here as well. And then finally, we've heard from a lot of you that research data storage and data lifecycle management is really important. We see that as well when we talk to our peers around the SEC. And so we are working on essentially a white paper to help guide you all to both OIT services and services elsewhere to help accommodate your needs, regardless of the size, whether that's a few gig to 3 or 4 petabytes of data. So as soon as we get approval to publish that, we'll be publishing that to the community and on our webpage for future use. So, and then finally, for those of you who work in GIS data, the existing GIS team at UA that accommodated facilities and land management and some researchers has been rolled into the research computing team. And they are going to be redesigning and re-implementing their Esri ArcGIS infrastructure that we have here on campus to accommodate more researchers. So as that gets rolling, we'll give you information and keep you in the loop on how it's going. Finally, let me introduce Dr. We'll just skip that one. Let me introduce Dr. Liang Tian. He's a member of our OIT research team. He serves as our HPC engineer and science and engineering domain specialist. He received his PhD in material sciences and engineering from Iowa State and has served as a postdoc at the University of Alabama and at Purdue. For us, he focuses on HPC software, researcher workflows, education and training. And today he's going to be providing a tutorial on how to use Conda software to manage Python, R, Java, Perl environments for different research projects, including machine learning and AI. So as we know, Conda is one of those more powerful and popular software packages. It's ramped up a lot, especially for those who use Python. So without further ado, Liang, I'll turn it over to you. And please feel free to start.
Sure. Thank you, DJ, for the last introduction. And I just want to make sure everyone can hear me. So, I think let's get started. So, welcome to this tutorial. So I'm very excited to present a piece of software called Conda. So this software can be used to manage software projects in various programming languages such as Python, R, Perl, and many other languages. And my name is Liang Tian, so I'm the HPC engineer at Office of Information Technology. So I have been here since April 2020. So I would define the goal of this talk is to for users, right? So it's not, this is not a research presentation. So I would like to take this journey with you on how to use this Conda, and how also to let you realize how important and how powerful Conda is in help your research. I think the first question in my mind is, why do we need Conda in the first place? So I think the original motivation is that we need a tool to manage the software projects involved with machine learning and AI and many others beyond. So we have some scientific projects such as fluid dynamics and computational drug and discovery. So all this science needs some machine learning or AI models involved. So there's various machine learning and AI models involved. And we, of course, to use these models, we need some tools. So we have a very comprehensive set of tools online available free from many outstanding developers worldwide, right? So so that's one question, right? What's the tool to manage all these machine learning tools? So I think the Conda is the answer to this question. I think the next question I have in mind is, what is Conda? So let me give you a brief introduction on Conda. So Conda is a powerful package manager and the environment manager that you use with command line prompts at MiniConda for Windows and in a terminal window for Mac OS or Linux. So I think also the second concept that is very important is a Conda environment. So a Conda environment is a directory that contains a specific collection of Conda packages that you have installed. So this will create an independent software environment dedicated only to your own project, right? So basically, you have a research project. In this research project, you only want specific Python packages to do that. In another project, you may also want to use other Python packages. So in this case, you want different environments for them. So also this Conda environment is not restricted to one language, right? It can, so the one Conda environment can have mixed packages from various languages, such as Python, Perl, R, and all in one single environment. So the picture below shows that when we, so the scope of Conda, MiniConda, and AnyConda, this is three different concepts. So the Conda is the most basic one, right? It has the Conda tool to manage all other packages, to install, to update, to remove. And so the slightly bigger scope is MiniConda. So MiniConda includes the Conda plus Python and plus some base packages. So that so it's only very limited amount of base packages, right? But for the most broad definition is AnyConda. So they call it a distribution, which means that it not only include Conda and Python basic packages, it also includes the 150 high quality packages, right? So so we call it AnyConda distribution. And so this Conda concepts came relatively new, right? I think before 2017. So the typical environment manager is virtual env. So Conda replaced this old software tool as a new technology. So Conda. So when we talk about Conda, we usually most of the time it's talking about MiniConda actually, because when you're installing the MiniConda, you combine Conda with Python 3 and a small number of core system packages to make it work, right? You don't only want Conda. You also want some basis packages to let your environment work. And so when you install the MiniConda, you're not installing a full Conda distribution. So installing only MiniConda will encourage you to create separate environments for each project, as I talked a moment ago. So this will install only the packages you actually need for each project, and so this will enhance the benefits is to enhance portability and reproducibility of your research and workflows, right? Because right now, in the scientific research software world, the one important aspect is trying to make your scientific research software as reproducible as much as possible, right? So in this case, we need software tools like this. So another important software tool is Singularity. So it's to make your software environments contained in a container. So you're shipping the whole software along with all its dependencies and system libraries as a single container software for people to install and run. I think the next question is important. It's what can Conda do? So Conda can do a lot of things and in a very user-friendly manner. So Conda can quickly install, run, and update Python, R, Perl, and many other languages packages, right? And it also can install associated dependencies automatically. I think one of the most important things is it can automatically resolve dependency conflict. So this is where Pipe cannot do, right? Pipe cannot automatically resolve dependency conflicts. So this can cause some issues when you have all different Python packages installed in one single location. And Conda can create, save, and load and switch between project-specific software environments on your local computer or HPC. And I think this is the main reason we're using the Conda to manage the software environments. So Conda was created initially for Python programs, right? The Conda can package and distribute software for any languages such as R, Perl, Ruby, and Java, and et cetera, et cetera. So that's why it's a very powerful software tool. So everyone, I think it's important to know how to install the MiniConda for yourself, right? Though I have installed the MiniConda centrally on our UHPC for everyone, so it is available as a modular as a bash script, right? So you have to source this bash script in order to let it run, but also it's still important to install your own MiniConda under your own home directory, because sometimes you just want everything under your own control, right? You don't want others to say your environment, use your software packages. Then this is the steps. So I think the first step is to download the installer. So it's I think this is pretty easy to Google around. It's basically Google Conda install, I guess. You can find this link, and then you will see this screen. It says regular installation. You have to follow the instruction for your operating system. For our HPC, we're choosing Linux for sure. Then we are installed in the Linux OS, and also there's also instruction for you to uninstall. So how to install on the Linux system? So after you download the installer, you need to verify the installer hash. So in Linux, you can verify hash by this command, right? So this command is available on this website. So, and then you need to run this bash command to the installer file. So bash installer file called MiniConda 3, whatever sh. Then you follow the terminal prompt, and when you follow I think it's pretty straightforward to follow it. And then you have to reset the default installation location to your own home directory, right? Suppose it's my home directory, then it's called home LTIAN6, right? You have to change this to your own home directory. So when you follow that prompt, you will also see an option called Conda Elite. So this option will automatically adding the environment variable change into your bash RC. So this is good for your own installation. But in our own UHPC centrally installed Conda, so I do not use this Conda Elite. I just manually adding whatever environment variable change into the modular file in this Conda Elite shell bash script. So then if you source this Conda Elite shell, then you will be able to use this version of Conda. Then after we install the Conda, how to use it? So the UHPC's central installation of Conda can be used as follows, right? We have this bash script conda elite.sh. If you source it, you are able to use it. And after you source it, then you run the conda env list command or the conda info -envs command. So both those two commands give you the same information, and you will see the screen look like this, right? You will list all environments currently in this version of Conda. So if you have fresh install, the only environment you will see is the base environment, right? So when you just install the MiniConda for yourself, so you will only be able to see the base environment. So for this Conda installation centrally, the installation location is share apps MiniConda 3 install 1. Check out an existing env. So I think this is what we need to next, right? We need to check if you previously requested a software environment before. So when you have at the base environment, so you find there's an environment called TJS that may be suitable for your research. Then you can use the conda activate TJS command. Then the shell prompt will become the TJS. So you change from base to TJS, and then you're running the conda list command. So this conda list command can show you all available packages under this environment. As you can see, we have a bunch of packages available here, right? So I think the next important thing is to verify that we're using the package in the activated environment. So under this TJS environment, suppose we do which Python, it will show us that we're using the Python actually in the TJS environment. So this verifies that we're actually using the software in this environment, not the Python from the system side. Then if you are running the Conda info command, you can also verify that that we're in the TJS environment. So this Conda info will give you the active environment location. So I think previously most people use pipe to install the Python packages, but it's important to realize that the Conda also has its own pipe. So basically, each Conda environment has its own pipe. So at the base environment, we do which pipe, you will see that pipe is from the base environment, right? In this, then you do Conda activate or source activate TJS. Then you do which pipe again. Now you are seeing that the pipe we're using is in the TJS environment. So basically, the base environment has its pipe. The TJS environment has its own pipe as well. So it's important to realize this aspect. We need to use the pipe only paired with that specific environment when we try to install packages by pipe. So there's two other commands are very interesting. It's Pipelist. So Pipelist will show you all the packages installed under this environment, right? It's Pipelist only shows you the Python packages under this environment. So there's another important command called PipeShow lumpy. So this command will show you this lumpy packages where it is located. You can see that location is in shell apps, MiniConda 3, install 1, envs, TJS, lib, Python 3.8 set packages. So this is the lumpy package from the TJS environments. So this pipe show command is a very useful command to see the location of the packages you are currently using. And the next important thing is what if the environment don't have the packages you need, right? And so suppose you want to use the UHPC central Conda installation, you can request system admin to create a new environment for your project. So you need to click the UHPC portal to submit your request at this link. So, and yeah, so we will receive a ticket when you submit a request, and we will be able to address it as quickly as possible. The second aspect is if you can install the MiniConda on your own home directory to manage the projects. In this case, you will be your own system administrator. Sorry, as I talked in the previous section in how to install the Conda. So suppose you install your own Conda onto your home directory, then what's the next? So the next thing I think is to create a new environment. So how to create a new environment? So here's a list of helpful commands. So you can check a list of existing environment in Conda installation. Since you have a completely new environment, when you run the Conda env list command, you will only be able to see the base environment exists. And you can create a new environment by this command. It's Conda create dash name. Suppose I'm name it as my Pi36 project. So Python using the Python 3.6. So this will create an environment called my Pi36 project. So this in this environment, Python 3.6 will be installed. You can also create a brand new environment from a file. So if someone gives you their own environment file in this format, in the YML format, you can create a new environment from this file by conda env create dash name my env dash file equal to pass to this file to this environment file. The final command that is very useful is to clone a new environment based on existing environment. So you can use this command conda create dash clone my Pi36 project dash name my Pi36 project 2. So this project 2 will be a clone of my Pi36 project. So you have something to start with. You want to build something based on that environment to test something else. So this is what it looks like when you actually run those commands. So in the base environment, you're running the conda create dash name my Pi36 project Python 3.6. So you'll be able to say something like collecting package map data, solving environments, right? And it says you create a new environment located at shell apps MiniConda 3 install 1 in VS my Pi36 project, right? So you have a new environment with this name. So at the screen prompt, you will see an option proceed yes or no, right? You have to click yes, right? We have to pay attention to that. And there's an option called -y dash yes option will let you avoid this. So basically, if you are running conda create -y dash name my Pi36 project Python 3.6, right? This will let you install this new environment directly without you to type yes. So after we're creating this new environment, we can check a list of packages in the environment. If you run the conda list command, you will see the base packages looks like this, right? In the base installation, you already have a bunch of packages available like pipe, Python, etc. You have also the channel is usually conda forge. That's the default channel for conda. It also lists the different versions for these packages. So, but this clearly this base packages is not sufficient for our research. So we have to install packages on a specific environment. So how to do that? And here are some very useful commands. So you can check a list of packages in current environment by conda list, as I showed you just now. You can also use Pipelist or pipe phrase, but this will only show the Python packages. And also the conda list command don't need to be the exact match, right? So if you type conda list torch, so you will list all packages with the name torch inside it, such as PyTorch, etc. So partial matches are supported. The second command is how to check a list of packages in another environment. So you can use conda list -n the name of the environment. So this -n is equivalent to --name. So it is. So they are equivalents in conda. So the third command is how to install a package on the current active environment, right? It's a conda install scikit-learn Jupyter. So you can install 2 packages at the same time, or 3 packages or more. So if you run this command, or you can run pipe install, scikit-learn, Jupyter. I think both of them will work. The next command is how to install a package on another environment. Suppose you are in one environment, you want to install a package for another environment, how to do that? So the command is conda install dash name, my Pi36 project, scikit-learn, right? Yeah, you're trying to install scikit-learn into another project. The fifth command is install a package through a dedicated channel. So if you want to install a package from a specific channel, you can conda install dash channel, conda forge buttons. The next important command is list a history of changes in current environment. So this command is conda list dash revisions. So in this command, you can see a history of changes when you use conda to install the packages, right? So it will give you the date and time and which packages you installed during that time. And it also lists different revisions as numbers 0, 1, 2, 3, right? So suppose you want to restore environment to your previous revision. So you can use the command conda install dash revision 2. So this will restore your environment to the second revision you made. So this makes the conda looks like a version control system in some way. So after you install these packages, then I think it's important to install to know this piece of fact, right? You're not just install the packages, you're also installing all the dependencies, right? So this can be seen by conda list dash revisions. You will see dates. This is revision number 0. Since this is the base environment revision, right? The first time we are using conda to install to create a base environment, and the revision 1 is the second time we're trying to install scikit-learn and Jupyter into the environment. You will see in the revision 1, it has Jupyter and scikit-learn installed. And it also has all the dependencies installed. So I just show a few of them. So what is the next after your environment is ready with all your packages installed? Then it's probably to just start using it. So I have an environment called my Pi36 project. If you run with Jupyter, it will show that my Jupyter executable is in my Pi36 project bin, right? Then you're running the Jupyter notebook. Then it will open a web browser called eLinks in the HPC system. So to use the Jupyter notebook, but of course, typically you want to use Jupyter notebook from your local computer. Then you have to set up the SSH port forwarding to do that. So in addition to conda install, we can also use the pipe in the activated environment to install the packages, right? So I think I just talked previously a little bit. So suppose in my Pi36 project, if you type which pipe, I just want to verify the pipe is in my Pi36 project. Then if we can use this the pipe in this environment to install the pandas, pipe install the pandas, then you will see it's installed successfully, right? You can so this means that we can use either conda install or pipe install to install Python packages in conda. Both of them works okay. I think the next important question is, does the conda install and pipe install packages at the same location? So based on my test, clearly they do. So this is the suppose in my Pi36 project, so I previously installed the scikit-learn by Conda install. If you do which pipe, right, verify, I'm using the pipe in this environment. If you do the PipeShow scikit-learn, you see that scikit-learn is installed in my Pi36 project, and lib Python 3.6 set packages, right? So this means the scikit-learn is installed in my Pi36 project environment. So previously we installed pandas by pipe install, right? So let's check where this pandas is installed. So if you do the PipeShow pandas, it will show that the pandas is installed in my Pi36 project lib Python 3.6 set packages. So no matter you use Conda install or pipe install to install packages, they will be installed at the same location, right? This make them interchangeable when you're trying to install packages. So any differences between this Conda install and the pipe install? I barely notice any difference when using the Conda within the Conda environment, right? But if you are using the system default pipe, which is outside of the Conda software, so that's a different case, right? In a non-Conda age, when you don't use Conda, like 10 years ago, when you work with HPC, you install the Python packages by pipe, then you need to add -- user option since you are a HPC user, right? Because you don't have the root privilege to access. So you have to use the pipe install -- user scikit-learn to install Python packages in HPC environment. But now we are in our Conda age. So each environment is already a separate environment. So all this environment is on the Conda directory. So everyone can, everyone right now in the UHPC can have access to that directory. And there's no need to use the -- user option anymore when you are using Conda to install packages. So I think this is a huge advantage because it prevents users making mistakes. So, and also this, you can use either Conda install or pipe install to do it. So this is very flexible. And also another benefit is that after you activate a specific environment, so this Conda automatically config the environment variables to use the executable in the bin directory of this active environment. So as I show you before in the Jupyter, so also you activate an environment, and you don't need to set up the environment variables by yourself. Then you can directly use the executable by yourself. So this can prevent users to have some issues with the installation. So I think this is one of the many benefits of using Conda from these above points. So in a non-Conda age, so I think to further see why Conda is very powerful and beneficial, we need to compare with how things are done in a non-Conda age, right? Suppose this is example. Suppose we install the Jupyter Notebook by System Pipe, right? This is the installation instruction from the Jupyter official websites, right? You have to use pipe3 install -- user Jupyter Lab. You have to use pipe3 show Jupyter Lab to show actually your install, right? And then you have to config some environment variables to put it into your shell. For Bash, you have Bash profile, bash rc. You can set up some environment variables in this thing. And for newer Mac, you have C profile for JSH shell. So you have to put some kind of the new path into this shell. And then after that, you're able to run the Jupyter Notebook. But clearly, for people who, for users who don't know too much about the system setup, right? This user, they don't like this at all. So they don't want to set up these environment variables by themselves. So this is why Conda is also very beneficial. It's set up this environment variables by itself when you activate the environment. So also in a long Conda age, when you use the system pipe to install packages, where is the installation? Where is the installation located, right? You can use these two commands for Python 3, Python 3-m sites, right? It will show you some of the global sites and some user sites, right? Suppose this is on your HPC, right? I'm a user now, LTIAN6. So it will when you do the pipe install -- user, you're installing the packages in the home Liang Tian 6 local lib Python 3.9 set of packages, right? So clearly I did not use any pipe install -- user to install any packages. So that's why it says it doesn't exist. So if you use a Python -m site, it will show the Python 2.7 set of packages as well. So clearly I did use a Python install -- user option in the past. That's why this directory exists, right? This user sites directory exists. So in Conda, this pipe and pipe 3 works interchangeably. So we can see in the following, but this is not true for system pipe and system pipe 3, because for many of the system pipe and pipe 3, they are very independent. So they are basically two executable sometimes. So in this case, I'm under my Pi 36 project environment. I do which Python 3, right? Python 3 is in this environment. I'm trying to check whether I have a package called PyViral in this in my environment. Clearly it doesn't. And then I'm using pipe 3 to install the PyViral package. And then I'm running the command to check if I have the PyViral package again. Clearly it output something. So this means I have installed. So you can, so when you use pipe show PyViral or pipe 3 show PyViral, so other commands will give you the same PyViral installation directory, right? So all the PyViral is all in the same directory location. So it seems that pipe and pipe 3 works interchangeably. So the reason is pipe and pipe 3 in Conda are all pointing to the same Python 3.6. So also again, this is not necessarily true for system pipe and pipe 3. So so the pipe so we have the pipe and pipe 3 from this environment. We're going to check if we open this file, this non file, and we open these two files. The first line of each file gives you the same thing. When you open this two files, it all shows that it uses the Python 3.6 in the my Python 36 project bin directory. So basically pipe and pipe 3 are using the same, pointing to the same Python. This is why they can work interchangeably. So in Conda, the next question is how to update the packages in a specific environment. So clearly you can update the packages and their dependencies in current environment by the command conda update scikit-learn, right? It will update the scikit-learn to the newest possible version. If you're using pipe install scikit-learn dash upgrade or dash capital U, right? So either will work, dash upgrade or dash capital mu. So all these two commands works interchangeably. The second command, that is, if you want to update the packaging on our environment, you can use conda update dash name, your environment name, and then the package scikit-learn. Then the next question is how to remove packages on the specific environment. So you can remove one or more packages from current environment by conda remove scikit-learn scipy. So this will remove these two packages. You can remove one or more packages from another environment. You can conda remove dash name, your environment name, then the package name, scikit-learn and scipy. Then you also want to know how to delete an environment. Suppose you're right now in the environment you want to delete. Then you first have to run conda deactivate to be able to get outside of this environment. After you deactivate the environment, then you're running the conda env remove -n my pi36 project. So this will remove that project called my pi36 project. So I just want to share with you that Conda is the package manager not only for Python, it's also for R and Perl and many others. So here's an example for R. So we have so it's very similar to Python. So you are using conda create -n R environment, R base. So this will create an environment called R environment. So it has all R base packages installed. Then you activate the environment like before. Then when you use conda to install the R packages, you need to add in the R dash before the regular R package name. For example, conda install R dash R Balkan, whatever that name is. You can use conda install R dash R Java. Then you will install these two R packages. You can also install R packages through the facial cran repo, right? Then you can do by invoking the R interpreter. If you type R in the terminal, then you can install R packages by install packages ggplot2 dplyr. You can add more packages here. But as my test shows that the packages installed by this approach will probably not show up in your conda list command. And you can update the package by conda update R caret, right? You can remove packages, conda remove R essentials. So this is all very similar to Python. So it's very this make it very easy to manage many different languages. So I think from what we see above, Conda has its own way of unifying managing packages for various languages, right? It also provides the flexibility to let each programming languages manage their packages in their own way. So I think this is the very wonderful software design principles that we should follow. So I think it's important to share with you what is a conda channel. A conda channel is the locations where the packages are stored. They serve as the base for hosting and managing packages. So the Conda packages are downloaded from the remote channels, right? So these are the URLs to the directories remotely containing the Conda packages. So this is very similar to PyPI when you use the Python pipe install to install packages, right? It's very similar to that. And you can use the CRAN for R. So it's very similar to CRAN repo for R. So this Conda information I showed before, if you run the Conda info command, it will show you what's the default channel you're using right now, right? We have a few channels here. So this channel is actually set up in the .conda archive file. So so if you do this, so in my own home directory, so I have my .conarch file in my home, right? When you print out, it shows a list of channels you're trying to fetch the repo from. You can also, it's important to adding a default search channel into your conda arc file. So you can do this by this command. So conda config dash add channels conda forward channel into the default channels, right? You can search select channels only for a single environment by putting a .conarch file in the root directory of that environment, or use the --infs option when using the conda config command. For example, this means that you can put a conarch file under the share apps MiniConda 3, install 1 enfs, and there's an environment called flowers. So if you put a conda-arch file under this directory, so the default channels for this environment will be in this file. So how to clone and reproduce environments if someone trying to ship their software environment to you to recreate. So along Conda H, we can create and clone environment by pipe, right? You are running the pipe phrase command, and then you're saving all output packages versions into this requirements.txt file. And then you can use the pipe install-r to install all the packages specified in that file. But you can also uninstall all those packages in the file by pipe uninstall-r option. So if you want to run it in a single command to uninstall, you can use this option to uninstall all packages. So this is the before we have Conda. It has this the how to clone is like this. But the downside of this is that it's only for Python packages, right? And another downside is that you can possibly have conflicts with existing Python packages. So in a Conda H, what we can do is to save the environment into a file and then send that file to other people, and then we'll recreate the file from the recreate the environment from that file. So you can run the conda env export to export all your packages in environment into a file. And with YML, then you can use this command, conda env create, that's its name, my clone env, to recreate this environment based on this file. Then you need to activate the environment, then your software environment is essentially cloned, right? So the advantages of doing this, you can save the whole environment for mixed packages, not only for Python, can for R and a bunch of other languages. and also it's a standalone newly created environment with no conflicts with existing environment, right? So it's you don't want your past packages entangled with your current installation. Another disadvantage of not using Conda. So in a long Conda age, it's very important to realize how Python programs find the packages and modulars. So there's something called modular search path. So if you and there's a link for you to Google to read. So the modular search path, how Python finding packages can come from 3 places. First place is current directory. Second place is the user setup Python path. The third directory is the system default installation directory. So if you import syst sys, you print the sys.path. So this will print all Python search path directories to finding modulars, libraries, packages, etc. So the second concept is user-side packages and global-side packages. So we use the dash user option. You are installing in the user sites, right? When you don't use the dash user option, you are installing the global sites. So
if you can pause a second, we're after 3 o'clock now. DJ sends his apologies, but he had to run and give a data center tour. And I wanted to thank you very much for this presentation. And
yeah,
I don't know if anyone wants to stick around and finish it and maybe ask questions.
Yeah, I think I almost finished it, so no worry. So basically, and then you can check the location of the user sites and global sites by these 2 commands, right? So you can by import sites, site get site packages, site get user site packages. You can do this. So none of the above basically is needed when you use Conda, right? You don't have to handle all this complex amount of stuff. So this is the summary of today's tutorial, right? We learned many of the core knowledge of Conda and Python, and also answer many of the core questions. We learned the standard practices of using Conda and a comprehensive list of hands-on commands of Conda. We learned many advantages of using Conda by comparing with the standard practices in a long Conda age, right? I believe with all this, you are a solid Conda user and you can feel free to explore its power. So there's a link for you to quick look up some Conda commands. So with that, I would like to answer any questions if there's any. So this is my contact information here, and we are HPC services. We provide a bunch of services here. And this is our OIT Twitter website. Feel free to follow it. So many thanks to Megan for promotion and DJ for moderating. So I think I've done talking and wait for any questions. So do we have any questions?
Hey, can I make a question?
Sure.
When I'm wondering, what about I have my own MiniConda, so when I need to submit the job, should I pass the path to my environment or not?
Yes. Yes. So it's like any other software you're using, right? So when you are using a software on your HPC, you're using modular load command, right, to use that software. But now, when you're using Conda, you're just using. Hold on. Okay. So when you're using Conda, you just you source this this file, right? Yeah, when you're on the UHPC, you just need to source. You need to source this file, share apps, modular files, Conda Elite.sh. For your example, you have your own Conda, you need to source that Conda environment. If your Conda is in your Conda setup, environment variables are in your bash RC, then you don't need to do anything, right? Then the next thing you need to do is to just need to Conda activate the environment, right? You need to activate your software environment, then you can run any other Python scripts or whatever, right?
Oh, I see. So I can source my own bash
Yeah.
RC.
So, yeah, exactly. It will carry on your Conda environment into the job submission script when you put the Conda activate environment command into the Snurm job submission script, right? Yeah.
I see. I see.
So
Thank you
yeah.
so much for your presentation.
Thank you. So do we have other questions? So if there's no other questions, I will just probably stop here and see you next time.
All right. Thank you, Liang.
Yeah. So thank you everyone for attending. So I think I will leave. So see you later.